Hi everybody, in this video I will give you an update on the development process of the version 2 of the BREmote. As you can see here, I finalized the mechanical design and this is what the version 2 of the remote is going to look like. So basically from the last time what has changed is that now the front and this top part is finished. The antenna is fully incorporated into the design. Other than that, the inputs and all of that mostly stayed the same. You can also see that on this remote I put on the second type of handle. So this basically is the handle for big hands. This is the little bit smaller version. And as said before, those handles can always be interchanged even after building the remote. So basically you're free to choose at any point which handle you would want on the remote. So with this, with the mechanical design finished, next step on here is to start filling the remote with epoxy or some other material to make it waterproof and then see how that goes. And also after filling to measure the antenna again and to see how the parameters changed and how we need to adapt that in hardware. The second part is that the receiver finally arrived, or actually it arrived quite fast. And that's what it's going to look like. So basically, as you can see, on the bottom, we have two UART ports, so we can communicate for once with the speed controller if it's a VESC. And we can also attach a GPS, which is interesting for speed measurement and also logging your speed and your position, similar to a meta module. On the top right here, you can see the outputs for two separate electronic speed controllers, and both of them are fully isolated from the rest of the circuit. And also below that you can see the input for two BECs, so voltage regulator, battery eliminator circuits. Also there's going to be a separate BEC board which can be plugged into the bottom and screwed on with the 4 screw holes you can see here. And that one will allow you to plug in anything from 18 to 75 volts and attach any kind of speed controller that doesn't have a BEC built in. And yeah, will make it quite easy to also use this kind of setup. Over here you can see the antenna port, and as you can see it's not one of those small UFL connectors, it's actually a big SMA connector, so it should be very sturdy and also last lots of times attaching and removing the antenna. Lastly, up here you can see two buttons, so like small push buttons, and they can be used for changing settings, for pairing the remote, all of that kind of stuff. Okay, so now let me show you what the remote can do and what I implemented in software already. So here you can see one of the remotes. It's currently connected to this battery, which later of course will be inside. And actually that's something I can show you on this model. So on this model I also included the battery already. And as you can see, it's basically a friction fit. There's a specific position where you need to insert the battery. In this case an 18650 battery. That's also the biggest that will fit the current housing, but 18650 will give you plenty of runtime of the remote. And then you can see this nicely fits and will be held in place exactly where I designed it to be. Okay, but yeah, in this one, as I said, small battery, doesn't really matter for what I want to show you. So at the moment there's also USB connected, so if I turn the remote on, it will recognize that it's charging. It will show you this indicator. If this indicator is moving, it is still in the charging process. If this indicator has stopped and will always show a full battery, it means the battery is fully charged. And on top of that, on the bottom here, you can also see the status. Obviously, the more red dots you have, the fuller the battery will be. Okay. So now let's turn the remote on without a charger connected. Quickly remove it. And then you can see if we power the remote on, it will tell you it's booting. It will tell you the voltage of the internal battery, and now it's in locked state. Now we can unlock it like this. It prompts us to touch the trigger once. And now it shows you a number. This number will later be the speed. At the moment it's a placeholder, that's why it's saying 10. And then obviously, like before, you can still set gears. On this one I limited it to the gear 4. So just you don't have to click that many times up to reach the highest level. And then of course I can lock it again by holding this, and now it's locked. So more or less this user interface has stayed the same. changed the graphics where I could. That's basically it. You can see on the bottom here, this is blinking, and this is the signal strength indicator. And obviously it's blinking because the RX is still turned off. So let me quickly supply the RX with power. You can see now it turned on. There's a light here, which means connection is good. Also down here you can see the level or the bar graph indicates we have a good signal strength. I can try to cover the antenna. Maybe if I pull it out, yeah, now you can see if I pull the antenna out, signal dropped. So this will give you an indication how good the signal strength still is. This over here is temperature and voltage, which at the moment also is just some simulated value, but also this obviously can go from 0 to full height. If I unlock now, you can also see we get some simulated speed data, which is just a counter ticking up. And also, if I touch the throttle now, you will be able to see our two servos are moving. And at the moment, the receiver is in the dual motor setup, so in the differential thrust. So you can see both of them are moving if I give it throttle. And then if I touch the steering, they move in opposite directions. So basically one slows down, one speeds up. Okay. So now let's pretend we never had this remote paired with the receiver. So let me quickly turn that off. And you can also see if the remote loses connection, the receiver also notices and tells you by blinking. So a few things that are new on the remote and on the user interface. If you hold a combination of trigger and toggle while turning on, you can get into, let's call it sub-menus. So for example, if I hold it to the right, turn it on and wait for it to be booted. Right now it will tell me pairing, PA for pairing. In order to pair the RX, I need to hold the pairing button pressed while turning it on. So let me do that. Now you can see it's also in pairing mode. Now I quickly push here and it says save. So that means pairing worked and it has saved the it's the same, but it has saved the pairing into its memory. And obviously, as you can see now, we still have connection and we still get this indication, and also we can steer the servos again. Second thing you can do, which is quite handy in my opinion, if you push the toggle to the left and turn it on, it will boot. And now it will be able, so EC means error calibration, off means hands off. Now please push the trigger fully. Now please push the toggle to the left and to the right. And also here it will tell you saved. And easy as that, without a computer, without anything, you can recalibrate the magnetic ranges of both inputs. There are a few more options. You can delete the config or reset by holding the trigger pressed and pushing this to one side. But yeah, I won't show this in detail now. I think this is good to get an overview. Now, for changing the settings in the earlier versions, you remember you had to change in the code some defines. This also has changed. In the future, this may be able to be done with Bluetooth or Wi-Fi, but for now you can do it with any serial terminal without actually uploading code. You can just talk to the remote. And let me quickly show you that. And now you can see I can talk to the receiver. So by putting in a question mark, I get all the commands I can do. You can see it here. So for example, I can say $conf to read out the configuration. And then it will tell me, first of all, that's the RX, the MAC address, software version. This is important. If you have a problem, then you can just send this information to me and I can help you. And also it gives us this like config string, I would call it. And with this, at the moment, we can open a website. As I said, later this may be implemented in an app or something like that. Just like that, put this here. And now what we can see down here is we have a list of all the configuration values that the remote currently has. This in the top is like the radio preset. So if you're in the European Union, you put this to 1. If you're in US, you put this to 2, and so on. The RF power, you can see at the moment, is at -9. That's the lowest it will go because I'm at home and don't need like a big range. Steering type, right here. This is interesting, and we will actually change that to a different value now. So here you can change normal e-foil mode, tow buggy mode with differential steering or with a servo. So by setting it to 2, I set it to servo now. You can set more or less the sensitivity of the steering. You can invert the steering. You can trim the steering. So that means if your boogie is always going a little bit to the left or the right, with this value, you can make it, you can basically make it go straight. So no more changing the PWM values. It's just this value from basically -100 to +100, make it go left and right. Right here, you can set the timings. So minimum, maximum time for ESC 1 and 2. So also the problem we had with the ESCs, sometimes you need to tweak this to 1550 and then the stop value to 1900 instead of 2000 to make the ESCs work properly, and you can do this here. How long of a lost signal until fail-safe sets in, and then some other values, battery voltage and so on. I won't show all of them in detail now. But basically what we can do now is click on export config. We can copy that here. We can also, to double check, we can paste it here, and then it will show us what we changed. And you can see the only thing I changed here is the steering type, which is what I wanted. So now we can go back to the serial monitor and set conf, add the config. Now it will tell you it's saved it. And now to apply it, we can just either go with apply config, or in this case, I'm going to do a reboot. So just like that, we can see the RX has rebooted. And now the system should be in the servo mode. So let's see if that worked. Let's unlock the remote first. And now we can see if I give it throttle, only this motor moves. And if I steer, the steering servo will obviously move from left to right. So from, steering left and steering right. We can also do some other things on the computer. So for debugging, for example, as you can see down here, we can also have the radio signal strength printed. We can have the PWM values printed. So let me quickly show you that. We can say print PWM, and now right here we can see the 2 PWM values it puts out. And you can see if I give it throttle, then obviously the first value goes up. And if I steer, then the second value will change. Like that, from left to right. So that's some handy tools. Also with quit, we can of course end this. That's just some handy tools we have now, and we don't need to flash the software all the time. And as I said later, this could be implemented in some app or online somewhere. Okay, so as you can see, basically we have a more or less working product here. A few things that are missing are communication to GPS and VESC, as well as the data logging. But as I said, I will bring this in the second step. First step is going to be make a waterproof remote and then see how all of this behaves on the water, what our final range will be, all of that. With that, that's all I wanted to show today. So thank you for watching. Have a great time. See you next time. Bye.